we're trying this here, we're going to look at angle relationships. And when we look at angle relationships, I'm going to look at a couple of things. The very first thing I'm going to talk about is vertical angles. So the very first thing I'm going to talk about is vertical angles. So that means that when two lines intersect, it creates four angles, and the opposite angles are known as vertical angles, are congruent. So what does that mean? That means that this angle and this angle, they're across from each other. They are opposite angles, they're congruent, and then that this angle and this angle, because they're also opposite angles, are also congruent. The next thing I'm going to talk about is supplementary angles. And supplementary angles are angles that sum up to 180. Angles that sum up to 180 degrees. So this can be angles that add up to 180 degrees, or angles that create or compose a straight angle. So let's say I have angle here and an angle here. So this angle and this angle are supplementary because they create that 180 degree straight angle. Cool? And then we're going to talk about triangle angle sum theorem. Triangle angle sum theorem. And that says that when I have a triangle, the angles in the inside of the triangle will always sum up to 180. Okay? And then the next thing I'm going to talk about is parallel lines and transversals. So that says parallel lines and transversals. So if I have two parallel lines and I'm going to cut it by a transversal, I'll cut the transversal in a different color. I now have 1, 2, 3, 4, 5, 6, 7, 8. So there's a couple of angles that are congruent. Why? Because these angles that are created are identical in the intersection. First part is because these lines are parallel and because they're being cut by the same line. So if we notice, we're looking at corresponding angles are congruent. So corresponding angles are congruent. And corresponding angles is, notice I have four angles intersecting that are created from this intersection, and I have four angles that are created in this intersection. So let's describe the position here. I have angle 1 is top left, angle 2 is top right, angle 3 is bottom left, angle 4 is bottom right. And over here, angle 5 is top left, angle 6 is top right, angle 7 is bottom, angle is bottom right. So if we notice, angle 1 and angle 5 sit in the same position. Angle 2 and angle 6 sit in the same position. And then angle 3 and angle 7 sit in the same position. And angle 4 and angle 8 sit in the same position. So corresponding angles are congruent. The next thing we also know is alternate interior angles are congruent. So alternate means one of them is on the left, the other is on the right. Interior means inside the parallel lines. So the four angles that are inside my parallel lines are 3, 4, 5, and 6. And so where it says alternate interior, this one's top left, this one's bottom right. Notice that they have the same congruency markings, so they're congruent. And then over here, this one is top right, this one's bottom left. So you see how their description even alternates, but they're both of those angles are inside. So those are also congruent. And then we also have alternate exterior. Are congruent. So notice outside of the angles, the outside angles outside of the parallel lines is 1, 2, 7, and 8. 1 is top left, 8 is bottom right. So they're alternate in position and they're congruent. So 2 and 7 are also congruent because they're alternate exterior. Awesome. So those are the things that I'm going to talk about in my next little activity where we're going to derive all of these angles. So I have this information is given. Given, I have line M, line N are parallel. So I'm going to go ahead and draw those two lines. So we'll call this line M and line N. And then it's going to have some couple of transversals. Here's one. And then let's do another one here. Here's another one. And then I have a couple of angles being created with all this. So I have angle 2, angle 3, 4, 5, 6, 7, 8, 9, and 10. And I have a couple of angles that are given to me. So I know that this particular angle here is 120 degrees. And I know that this angle right here is 55 degrees. So the very first thing I'm going to do is I'm going to say the measure of angle 1 is this, and then I'm going to put a reason behind it. So I'm going to create a statement, and I'm going to say why, and then I'm going to make a reason. And then I will always tell you why it is. So notice right here, I have 120 and angle 1 make this straight line right there. And that straight line is going to be supplementary angles. So I know that if this angle is 120 and this angle here together make 180, I know that angle 1 is equal to 60 degrees. So we're going to mark that one as 60 degrees. And I'm going to call that supplementary angles because of supplementary angles with that given 120. Cool. Now, I know angle 2 is 120 degrees because notice two lines are being intersected here. Opposite angles are called vertical angles and are congruent. So I know that this guy right here is 120 degrees, and I'm going to call that vertical angles. So I'm always giving you the reason why these are happening. And then, for that same reason, I'm going to say angle 3 notice angle 1 and angle 3 are vertical angles, so I know that angle 3 is 60. And again, that's a vertical angle that I'm using. Cool. So I'm going to mark that as 60. Okay. And then I now recognize, remember when I said when two parallel lines are cut by a transversal, corresponding angles are congruent. Corresponding angles are angles that are created in that same position. So notice I have 4 angles being intersected here, and this top left matches with number 4. So I recognize that number 4 is also going to equal 60 degrees. So angle 4 is 60 degrees, and that's because corresponding angles. And that happens when two parallel lines are cut by a transversal. So this angle and this angle are corresponding. They're sitting in the same position of that intersection. Notice now I have angle 4, angle 5, and this 55 degree. So all together they give me this straight line. So I have another supplementary angle situation happening here. So I'm able to derive that 60 plus 55. So here I'm 60 plus 55 gives me 115. If I subtract that from 180, it gives me 65. So I now know that angle 5 is 65 degrees. 65 degrees. And I'm going to use supplementary angles to validate that. Angle 5 is 65 degrees, and I'm going to call that by supplementary angles. Cool. I noticed that angle 4 and angle 6, these two lines are intersecting, and angle 4 and angle 6 are vertical angles. So angle 4 and angle 6 must be congruent, so that means that angle 6 is 60 degrees because of vertical angles. Okay, and then looking at number 7, these two lines right here, this blue line and this green line are intersecting, creating opposite angles known as vertical angles. So I now know that if angle 5 is 65, angle 7 must also be 65 because vertical angles are congruent. Okay. Now notice this blue line and line N are also intersecting, and I'm able to say that angle 8 is going to equal 55 degrees because of vertical angles. Okay, and now looking at 9, I have a triangle right here. See that triangle? And in this triangle, I don't know what angle 9 is, but I do know that angle 3 is 60 and angle 5 is 65. 60 plus 65 is 125. If I subtract 125 from 180, I get 55. Angle 9 is 55 degrees. And that's through triangle angle sum theorem. Triangle angle sum theorem. And lastly, notice that these two lines are intersecting. Angle 9 and 10 become vertical angles, therefore they are congruent. So that means that angle 10 is also 55 degrees. And just like that, I was able to figure out all of the angles in my diagram. Hope this helps.